So now that we've finished up with SearchTaskGangCommon, it's time to start taking a look at some of the subclasses of that superclass that customize it to do more specific kinds of searching, particularly with respect to concurrency models and synchrony versus asynchrony approaches. So we're going to start by taking a look at the OneShotThreadPerTask subclass. And this is something that overrides SearchTaskGangCommon, which in turn overrides TaskGang. So it's not directly extending TaskGang, it's doing it through SearchTaskGangCommon. And you can find the code here at this link, GitHub repository. So what does this particular class do? It customizes the SearchTaskGangCommon superclass to do a one-shot search for words in a list of string objects using virtual thread objects rather than by using a thread pool. All the other examples we're going to look at use thread pools. This one does not. This uses virtual threads. This is where you can get the code. So let's take a look at the way it works. It's going to have a thread per task, really a virtual thread per task executor model. The unit of concurrency will be a virtual thread for each input string. Each input string will be processed in a separate thread. And the results processing model is so-called synchronous processing. The main thread of control is just going to wait for all the other stuff to be done. So here's what it looks like. This is the constructor, and it's got this initiate task gang method in it, which is called when the run begins. And it's going to create an executor that will start a virtual thread per task. So we're actually using the executor framework, but we're doing it in such a way where we're going to have the execute method start a new virtual thread for every runnable. And this is kind of cool, actually. So if you take a look here, you can see that we say set executor, and then we pass in a lambda expression, which is going to be used as the executor's execute method. Remember, executor has an execute method. Executor is a functional interface, and therefore it has a single abstract method. And you can see here what that abstract method does when it passes a lambda expression is going to start a new virtual thread to run the runnable and then add it to the worker threads list. And what it does after it creates that executor is it goes through for every element in the input, and it says, hey, executor, execute this particular task that's being made here for this element in that input list, which will then go off and create a virtual thread as we see up above. So a really clever way of using the executor framework to get us this virtual thread per task model while still staying within the bounds of the executor framework itself. So each virtual thread is stored in a list, and the way that the processing gets done is the process input hook method, which is overridden by OneShotThreadPerTask, is going to iterate through all the words to find. And for each word, we're going to call the search for word method. And keep in mind that this process input will be called for a given input string. So for example, one of the input strings that we get from our example, it'll search for all the words in one thread. All the words defined will be searched in that one thread. And you'll also notice that if we get a match, we're not queuing anything up. So we go ahead and print the results. And we synchronize this because we don't want to have the results scrambled because it's going to be printed from different threads. The main thread, which is the one that's ultimately calling run in the SearchTaskGang test driver, will call the join method on each of the worker threads. So you can see here what we're doing is the main thread will join all the worker virtual threads using this little loop down here. This is a Java for each loop, and for each thread in the worker threads list, we're going to go ahead and join. And once again, we're using rethrow runnable just to make things a little bit less ugly with try-catch block stuff. So let's go ahead and walk through the code and see what this does. So here's the code for OneShotThreadPerTask. You can see it extends SearchTaskGang. It's got this list of worker threads. That list of worker threads is initialized here in the constructor. We also initialize the words to find and strings to search parameters by calling up to the superclass, which is SearchTaskGangCommon. And now we've got ourselves a linked list of worker threads. We could make an array list. I just did a linked list. Here's initiate taskgang. This is the one that's going to create an executor where the execute method will start a virtual thread and then add that virtual thread to the list of worker threads. And it will then have this run. It'll actually go ahead and run that runnable in a virtual thread. And then down here, we iterate for I equals 0, I less than the input size, and we call make task, which will go ahead and give us back a runnable to execute the element at index I, and we execute that, which will run in the virtual thread. Here's what gets run when that happens. It calls the process input hook method, which just loops through this for each loop, searches the word using search for word that it inherits from the SearchTaskGangCommon superclass. And as I said before, we have to synchronize the output here because otherwise we'd have all these different threads trying to print things out concurrently, and it would scramble things and make a big mess. And then finally, here's the await task done method, which just iterates through all the thread objects and joins them all, or waits for them to be done and then joins them. So that is one-shot thread per task, a very interesting use of the executor framework in conjunction with Java virtual threads.